a quadratic equation, but we're going to do it with the minimal amount of algebra possible. So here we're going to make everything equal to 0. Remember, when we solve a quadratic, the balancing method all the way down is not going to work. It will only work for linear. So let's go ahead and we're going to copy this down, and we're going to do one little tweak. I'm going to take that 10x, and that's going to go over to here, and that will be minus 10x, right? So subtract 10x from both sides. So we've got now 6x squared minus 10x plus 4 equals 0. We've done. That is the only algebra we need. So subtract 10x from both sides, and then look, we're going to use Polysolver. So go to our TI-Nspire, menu, algebra, polynomial tool. So polynomial means many terms. Find roots of polynomial. The degree of the polynomial is 2 because it has an x squared. This will also solve x cubed, so x to the 4, x to the 5. Press OK. And now can you see the format? It says a of 2 x squared plus a of 1 x to the 1 plus a of 0. So a of 2 is how many x squareds we have. And look, we have 6x squareds, so 6 goes here. A of 1 is how many x's we have. Important that we take the negative 10, and then we have a positive 4 at the end. Enter. Just have a quick check to see if it's the correct format. 6x squared minus 10x plus 4. Boom. Now these are the two answers. X equals 2/3 and x equals 1. Okay. If you now try it with the no algebra way, the graphing way, we're going to go get a graphing. Now to solve any equation, and this isn't just for quadratics, it's for any equation, anything with an equals sign where you want to get it down to x equals something at the end, we are going to take a graph of the left hand side. So x squared, I need to times it by 6, so 6 times x squared plus 4, enter. And sometimes you might see the graph on the screen, you might not. We might need to rescale the axes, and then tab, and now I'm going to put in the right hand side. So f of x equals 10x. Okay, and then we just want to know where these two graphs actually intersect. Okay, so you can do Control T. You can have a look at the table of values, right? So when x equals 1, here's the blue graph. Can you see on the screen? It goes, pretty much up pretty quickly. And then here's the red graph. Okay, so you can just do a little comparison here. Okay, now Control T will take the table off. Control T. Now it would be nice to zoom in on the important parts, and here's where you have to be pretty good with your calculator. You can either go and gently double click and then type in -1, enter, and maybe double click on here. I'm going to type in 4 and enter. Okay, that looks good. Or you can go to the menu and go through the full operation. I'm going to stick to this method because I think that top value, I'm going to go up to 20. Ooh, look. So I wonder if there's 1 or 2 intersections in this region here. Okay. Now we can go in and zoom in a little bit more with this. I'll show you. Menu, window zoom, zoom in, click, click. Can you see there does look to be 2 intersection points? All right. So now menu, analyze the graph, intersection, click a point before and a point afterwards. Look, there you go. Here's a solution. We've got x equals 1, right? I think that was a solution before, right? X equals 1. Let's go back. Yeah, x equals 1 was a solution. And then menu, analyze graph, intersection. Let's click and click. And there's the other intersection. Now notice this is given as a decimal, 0.666666 recurring, and that indeed is 2/3. It's okay if you write this to 0.667 to 3 sig fig. That would be good. So there's your 2 solutions. All right. So a recap. If you don't really want to go down the route of factorising, or you find factorising really tough, then there are 2 alternatives. The first one involves a tiniest bit of rearranging. We have to get it in the form ax squared plus bx plus c equals 0, and then we use the Polysolver. That gives rise to these 2 solutions for x. Or we do no algebra rearranging, and we draw a graph of the left hand side, a graph of the right hand side, and find the intersection points. Notice we just need the x coordinate because this equation is in terms of x.